All right, lesson 15. We are all on page 55 together, okay? So both fractions and decimals can be used to represent the parts of a whole. And I know you guys saw some of that. We started looking at this one on lesson 14. We looked at that as we were starting fractions, okay? So fractions to decimals. We talked and showed that we could do 3/4 written as a decimal is what? 3/4 written as a decimal. Think about 3/4 of a dollar is how much cents, right? 75 cents. So we just take away that dollar sign. 3/4 is the same as 75 cents, 0.75, okay? So if we look at 4/5 on that picture in your book, you've got that box split up into 5 equal sections, okay? So that's like the pizza, rather than having the circle and splitting it up into 5 parts. They've got bars. We could do the same thing here. We've got 5 bars and we shade in 4 of them. Okay, 4/5 is what we have shown. If we take that same pie, we can't say fifths into a decimal because that doesn't work. But if we change this, we can say that this is, we take it and cut it a few more times. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Anytime we've got 10 of something, that's like saying the 10th place. Okay? So the 10th place. So how many, we split this equally into tenths, how many spaces are colored in? 4/5 is the same as 8.8. Okay? Which is 8/10. It's the same. Just look at this. If we divide 8 by 10, okay, we said we divide, we move the decimal place to the left for division. If we move that decimal place, and our 8 is assumed to be back here, we move it one place to get 0.8. So 8/10, written as a fraction, is that 0.8. Yes, sir?
What about 16/20?
16/20 you could reduce, right, down to 8/10. So 16/20 is the expanded version of 8/10. That is true. On here?
Yeah.
We would just split each one of these little sections one more time. There's 16/20 colored in. Does that make sense? Okay, and when you reduce, you get down to tenths. Obviously, 8/10 can also be reduced, but for decimal purposes, it's way easier to get 8/10 into a decimal than 4/5. Do you agree? Okay, does everybody see that? Okay, beautiful. So, on the left, as we showed here, we have the 4/5. And we showed it on the right, we split it into 10 sections instead, okay? So, again, 4/5 to 8/10. We expand it, we just cut each section of the pie in half, okay? So, fractions to decimals. If we take a fraction, we can actually do the math, like we showed for 3/4 to 0.75, and figure out what our decimal point is. Some of them you guys should know off the top of your head, but others it's going to take some work. Like 3/8. I know 3/8 by heart because I've practiced it enough, but you guys are probably going to have to work on that and do some memorization. So right now, for 3/8, if you don't know it, even if you do, I still want you to show me the math. We're going to take 3 and divide it by 8. But what do we say? When you have a fraction less than 1, we're going to have to put that decimal point and put out some zeros. Okay? So there are no 8s in 3. So we've got 0 decimal. So how many 8s are in 30? Simon? How many 8s are in 30? 3. What's 3 times 8? 24. How many are left? 6. We dropped that 0. So Portia, how many 8s are in 60?
About 6.
Careful.
Okay, let's see.
No, Portia, he's raised his hand. You worry about you. How many 8s in 60?
About 9.
What's 8 times 8?
Yes, 1, 2, 3, 6, 10.
What's 8 times 8? Portia, what's 8 times 8? I'm not talking Portia. Nobody else needs to be talking Portia. 64. Is that too much?
Yeah.
Yeah, so if it's 64,
So
it's too much.
7.
So 7. So what's 8 times 7?
They're about
Jarvis.
9.
Drive 75
Do you agree with him? You shouldn't.
That's
I
wrong.
mean, no, I mean,
You should not be talking, remember?
Then
Right here. Quiet, I'm talking to Portia, okay? So Portia, what's 8 times 7?
56.
56. How many are left over?
About 4.
About 4 or exactly 4?
About 4.
Exactly 4 or about 4?
Exact.
Exactly 4.
Bring
Okay?
that 0.
Bring that 0 down. So Jamaica, how many 8s are in 40? How many 8s are in 40? 5. Is that exact?
Yeah.
Is your name Jamaica?
8 times 5, about 40.
Is it about 40 or is it 40? Ladies and gentlemen, I'm not playing. You gotta use the correct language. Okay? Is it exactly 40? Yes. So my decimal, 3/8 is 0.375. Okay, so you guys can do out the math for those. So it says to divide 1 by 30. So B, we've got 1 over 30. 1 over 30. Okay? Again, what are we going to need to do? What are we going to do, ladies and gentlemen? Give me some hands. Talk me through this one. Travis?
Add a decimal.
Add a decimal. And some zeros? How many?
4.
4 of them? Okay. So, how many 30s in 1?
9.
None. Bring up that decimal. Don't forget that. How many 30s in 10?
9.
None. How many 30s in 100?
3.
3. What's 3 times 30?
90.
90. How many are left?
100.
How many are left?
100.
How many
10.
are left? 10. Then we drop that 0. How many 30s in 100?
90. 3.
3. 90. How many are left?
10.
10. Drop that 0. As we can see, this one is repeating. Okay? So, 1/30th is that decimal there. Okay? 0.0333. If we kept going, that 3 would continue on forever because every time we do the math, we're going to have 90, so 10 left over, drop to 0. So 0.0333. So one of the things that we're going to talk about today, and make sure that we understand, is repeating signs. You guys know that bar over top. So if we have this, and I say to write it with the repeating bar, okay, it's called the repetend. How am I going to write this with a repetend? Travis?
0.033 bar. I mean, 03 bar.
Bar. Good. We only want to put one of the 3's. Okay, so the 0.03 with the bar. So this is written to 2 decimals here. You've got the repetend, the repeating bar, so you've got it taken care of. Okay? So that is great. Okay, so my first one, 0.375, B, 0.03, repeating. Okay? Make sure that you do not let this repeating bar wander over above that 0. Okay? What would that mean? If the repeating bar was over the 0, and I were to expand it, Jamaica? 03, exactly. But that does not look the same as that, right? Okay, so be careful that that repeating bar, the repetend, only goes over the number that you want repeated. Okay? Just something to watch out for. Beautiful. The bar over the repetend, so this is our repetend, is 0.3 repeating, is called your vernaculum. So this little dash over the top is your vernaculum. I don't expect you guys to know that one on the test. Just make sure that you know where to use your vernaculum. Okay?
Okay.
Alright, so if the denominator of the fraction is a power of 10, like we said originally with our 0.8, or 8 over 10, okay, we can divide that mental math like we did before. So it's a simple way for you guys to turn tenths into decimals. Okay, let's all turn our page. We're on 56. So, write each fraction as a decimal number. So 3 over 10, let's just do these verbally. 3 over 10, written as a decimal, is going to be what? I need some hands. 3 over 10 will be what is a decimal? Destiny? 0.3. Good. She took that 3, divided by 10, and 10 has 1 0, so she moved the decimal place 1 time to the left, so 0.3. Okay, B, 2/5. What do we say? If you have fifths on the bottom, we can expand that so that we get what as our denominator, Jarvis?
0.2.
Careful, if it's 2/5, you're going to need to expand 2/5 to get what is your denominator?
10.
10. So what did you have to multiply 5 by to get to 10?
2.
Times 2. Whatever you do to the bottom? top, so 2 times 2 is
4.
4. So 2/5 written as a decimal is
Oh, 4. I mean, 4.
0.4. Exactly. 0.4. Good. Okay, and then 3/20ths. Okay, this one's kind of the reverse. Idea, Jarvis?
0.06.
Not quite. Let's look at this one real quick. Okay, if we've got 20ths, 3/20, and we make that into tenths. This is not a correct fraction. You can look at it. If you take 20, how did you get from 20 to 10?
Reduce.
Okay, what did you reduce it by?
10.
By 20, you had to do what to 20 to get to 10?
Divide by 2.
Divide by 2, exactly. Divide by 2. Please leave that chair alone, okay? So if we divide by 2 on the bottom, what do we have to do to the top? By 2. Okay, what is, you can't actually do the math for 3 divided by 2 and get a whole number, right? But we all know what 3 divided by 2 is. Do we?
No.
What's 3 divided by 2? 3 divided by 2. 1.5. Okay? Again, not a correct fraction if you were to be writing in fractions, but for decimal purposes, rather than do out all this math, you could reduce it to a really ugly fraction, and we can still do that mental math. Since we're dividing by 0, that means we're just taking this decimal and moving it 1 time to the left. So 3/20ths is 0.15. See it? We take that 1.5, we move the decimal 1 time to the left because we divided by 10, the power of 10 rule, we get 0.15. Does everyone see that? No? Jarvis, where are we going wrong here? Do you understand reducing 3/20ths to 1.5/10? Yes? Okay, when we do the powers of 10, like here, you divide by 10, right? That's how that decimal place got from behind the 4 to in front of the 4. Eyes up here, sir. Jarvis. Okay, so 4. The 4 was back here before, but because of this 0, and we're dividing, if we divide, that decimal point goes left, right? So if it goes left 1 time, it started here, it went there, so my answer was 0.4. Same here, if I was 1.5/10 originally, and we divide by 10, so 1, 0, means we move the decimal place 1 time to the left, we get 0.15. Does that make sense? Yes? All right. That big scary paragraph, would somebody read it to us? Nice and loud. Somebody read me that big long paragraph, please. Nice and loud. I need some class participation here, ladies and gentlemen. Go ahead, Portia. Nice and loud.
Every fraction can be written as a decimal number. To write a fraction of a whole number as a decimal number, we divide the denominator into the numerator. The answer will always be either a terminating decimal number or a
Repeater.
repeater. A decimal number that repeats in a definite pattern sometimes. It is easy to see whether the digits terminate or repeat. Other times there were a large number of repeating digits in the pattern, and the pattern is not easy to see. When this happens, we just round to a convenient number of digits. When writing a fraction as a decimal number, it is important to remember that if the number does not terminate, the repeating pattern is always there, even if we do not immediately see it. We show several examples here.
Good. So 1/8, when we do the math, 8's 10, except for 4/8, because that's 0.5, 1/2. Okay, they'll be 3 digits long. 125. We saw 3/8 was 0.375. Okay, so 1/8, 0.125. B, 3/7. If we were to do 3/7, you see that that number goes out how many spots? 1, 2, 3, 4, 5, 6 spots. 4, 2, 8, 5, 7, 1. Then it repeats. 4, 2, 8, 5, 7, 1. Then it repeats. 4, 2, 8, 5, 7, 1. So we could put that bar over that whole 5, 2, 8, 4, 7, 1. Okay, so that one is a repeater also. We've got 21/99. It's 0.21, 21, 21, 21. So we could put the vernaculum over the 21. 0.21 with the bar over the 2 and the 1. Okay, for 0.833333, so for 5/6, how would we write that if we wanted to write it easily? If it's 0.833333, what could I write to show this one in a simpler form? I obviously can't keep writing 3's on forever, so Jarvis, what would I put? Go ahead.
0.84.
Okay. If I want to keep the integrity of the number,
Oh,
if I don't want to round,
Point. Bar over the
point what?
8.
0.8
Bar over the
bar over just the 3 or the 8 and the 3? Just the 3, exactly. So 0.83. This is the simplified version with my vernaculum, the repeating bar over the 3. Okay, you didn't put it over the 8 because we don't see the 8 in every other spot. We just see the 3 repeat. Beautiful. Okay, so when we round repeaters, it's going to be the same way that we rounded decimals before. Okay? The only difference is going to be, it's going to tell you which place to round it to. So let's look to our first example, 42.617. So 42.617 means that 617 does what? The bar is over the 6, the 1, and the 7. So if I were to write this out, it repeats. So Jarvis, what would come after 617? 617. Then? 617. Good. So if I'm told to to round to the nearest millionth, which number is in the millionth space, and am I going to circle here? Give me a hand, Jarvis.
The 6.
Which one's in the millionth? Third 6. Careful, let's count them.
10.
Keep going. 10,000.
10,000.
Millions.
Oh.
So we're going to circle the millions and look to which one?
The 6.
The 6, exactly. So if I round this number to the millionth spot, what's my number going to be? If I were to rewrite it. Jarvis, keep going for us.
It'll be 8.
Sitting down, Tamika.
I had to.
Good. So 42 point, read me the whole
6,
rest.
7.
6,
617.
17, 8. Beautiful. So this is that one rounded to the millionth space. Okay? Beautiful, Jarvis. Thank you. All right, so decimals to fractions is our last little section. So both terminating and repeating decimal numbers can be written as fractions of whole numbers. The method of writing repeaters as fractions is rather complicated and will be taught in a subsequent course. You guys won't see that until really late in Algebra 2, okay? I'm pretty sure it's the first time that you'll have to figure those out, okay? So the crazy, scary numbers we won't worry about. You guys are going to be able to do the simpler ones. Yes, ma'am?
So after this is as a 1, right?
Yes, then geometry, then Algebra 2.
Oh, so geometry is before algebra 2?
Yes. Okay? So, if we take 3/10, we said, yes, sir?
No one knows me.
Some. Let's keep working on this. I've got 3 more minutes to finish our lesson, okay? All right, so 3/10 is a decimal. We've got 0.3. That one was easy. If we saw 0.7, how could you write 0.7 as a as a fraction? How would we write 0.7 as a fraction? 0.7 as a fraction. Give me a hand. 0.7. I need to write 0.7 as a fraction. Jamaica? 7 over
10.
0.7. Go ahead, Jamaica. 7 over what?
I don't know it.
Okay, what space is that 7 in? What's this space called? When we named it over here. So give him that, what is it? 10.
Place. Oh, no.
Make sure you, exactly, make sure you got that on the end. The 10th place. So when we see 0.7, we can take 7 and put it over that place that it's in. So 7 over 10, okay? You don't remember that it was over 10 to give us one digit. Okay, if we had 778, how many spots, what digit, what place is this one in? Damon? What place is my 8 in? The hundredths. So what am I going to put 78 over? 100, exactly. 78 over 100. Could I reduce 78 over 100?
Yes. Oh, not bad.
Could I reduce it?
For me?
Anybody?
Of course.
could by what? Jarvis? 2. Okay, 2 would be the easiest first step. I'm not going to make us do that right now, but you could reduce this one by 2. Okay, so when it says to show me the fraction, if it can be reduced, you do need to reduce it. Okay, so 78. So you can see we took 78 because that 8 was in the 100th spot. It goes over 100. That 7 was in the 10th spot, so it goes over 10. Okay, so we've got that first example, 0.041 as a fraction. So we've got 0.041. What spot is that 1 in? Destiny, what spot is this 1 in here? The thousand. So what am I going to put over 1,000? For this number, if I'm turning it into a fraction, ladies, what am I going to put over 1,000? 41. Good. This 0 is kind of like when we were writing the numbers. We don't have to include her over here. She's just kind of invisible. Okay? But 41 over 1,000. Right? And that, 41 is prime, so this cannot be reduced. Okay? So this is the simplest form that this fraction can be in. Okay? Good. Last but not least, yes ma'am?
I'm going to have trouble with this stuff. It's a lot of stuff to remember.
There is a last step. The key is just looking at the last space that digit is in, and that's what you get to put it over. It's always going to be the tens or hundreds or thousandths. Up here it would be 10 millionths, right? Or millionths, I think we said. So this number, you could say, is 42. We write a mixed number as 617, 618 over 1 million. Okay?